So what I'm going to do today is briefly sketch out for you the way that economists think about decisions that involve risk or uncertainty. So up until now, everything that we've done in this class has assumed that people know the consequences of the decisions they're making. If you're a consumer and you decide how many pupusas to buy, how much housing to buy, you know that if you spend a certain amount of money, you'll get a certain number of pupusas, you'll get a certain amount of housing, you know how much you'll like those things. If you're a producer, we have assumed that you know what your costs are, right? You know the price at which you're going to be able to sell your output. So you were able to make a best decision, right, without any lack of information, without having to take any risks. Of course, in the real world, this isn't true for most of our really important decisions. As a consumer, right, or you as an individual student, when you made the decision to come to Occidental College rather than to go to college somewhere else, a lot of the most important determinants of whether that was a good decision or not were unknown to you. You didn't know who your freshman roommate was going to be. You didn't know whether the professors were going to be very good, right? You didn't know what exact classes you would want to take. You might not even have known what major you would be interested in pursuing. So at some level, you had to weigh the costs and benefits of, you had to make educated guesses about what you were likely to get at Occidental versus what you were likely to get at some competing college. And this is true of all sorts of important consumer decisions, right? If you decide which city to move to, you decide which job to take, if we think about you as a supplier of labor. If we think about your decision to buy a car or buy a house, all of these are decisions where you might not know all of the pertinent information when you're making those choices. And of course, this is true for producers as well. If I decide to start a restaurant, I have to make a guess, right? I'm uncertain about the amount of demand that my restaurant's going to face over time. I don't know whether people are going to like the food. I don't know if there's going to be a global pandemic, and I have to make a decision that accounts for those sorts of risks, right? Regardless of what I'm producing, I might not know whether a competitor is going to enter the space, whether technology is going to end up making my product more or less valuable. I have to make decisions accounting for all of those risks. So the first thing we're going to do today is build a framework to think about how people ought to think about those sorts of decisions, right? Come up with a framework where we can take our ideas of utility maximization and optimization into risky problems. Once we've done that, we're going to think a little bit about markets where people trade risk with each other. In other words, with insurance markets. And we'll think about how those markets are affected by information asymmetry and moral hazard, which really comes down to how those markets are affected by violations of our welfare theorems. So let's start out with an incredibly simple, risky decision that you might have to make. Let's say that as a prize for watching an optional lecture video, I give you a choice of two options, right? You can get two prizes. Option A is that I give you $1, and option B is that I give you, I'll flip a coin, right? If the coin lands on heads, I'll give you $3. And if the coin lands on tails, I'll give you nothing at all, right? I'll give you $0. So think about what you want to choose, right? Make your decision. It's tails. None of you get any money. So most of you probably chose option B. It's okay if you chose option A, right? Everyone's allowed to make their own decisions. But most people, when offered this choice, might think that $3 half of the time is better than $1 all of the time. And there's a certain logic to this, right? Because you'd say, on average, if you were offered this a whole bunch of times, right, the average amount of money you make from option B is higher than the average amount of money you make in option A, right? As a result, you might say, B should be better than A. And this is a thing that we can formalize a little bit. What we can say is we can say that the expected number of dollars in B is greater than A. What do we mean by the expected number of dollars? Essentially just the average of all the things that might happen, right? The expected value of some X, right, some choice X, is just going to be the probability of each possibility happening times the value of that possibility, right? So P1 times X1 plus P2 times X2 plus P3 times X3, so on and so forth for all of the possible outcomes of our risky bet, right? So in this case, we would say the expected value of A is just, there's a 50% chance you get heads, 0.5 times 1, 50% chance you get tails. 0.5 times 1 is just 1. Expected value of B, 0.5 times 3, right? 50% chance of heads, plus 0.5 times 0, right? Which is going to be 1.5. So it's reasonable for us to say, right, on average, you'll make $1.50 in option B versus $1 in option A. So clearly, right, option B is the better choice. Cool. Great. Super straightforward. Now I'm going to make a tiny, tiny tweak to these two options. A really insignificant tweak. Right? It's not going to change any of the math I just did at all. Now I'm going to say, instead of giving you $1 for sure, I'll offer you $1 million. And instead of giving you $3 if you get heads, in option B I'll give you $3 million. But still nothing if you get tails. Right, so the relative expectations haven't changed at all, right? Expectation of A is still going to be 1 million. Expectation of B is going to be 0.5 times 3 million plus 0.5 times 0 is going to be 1.5 million. So clearly, right, everyone's going to still choose option B. Right? Who cares that you might miss out on $1 million for sure? Right? Everyone feels comfortable with this, right? So personally, I do not feel comfortable picking option B in this case. I would totally pick option B when we're talking about $1 versus $3. If we're talking about $1 million versus $3 million, even after seeing this calculation, I am definitely taking $1 million for sure. Right? So why is that? Why might I do that? Why might I not be willing to risk my $1 million? Well, for me personally, what it really boils down to is $1 million would completely change my life. Right? $1 million, I could buy a house in Highland Park or Eagle Rock. I could take a bunch of leftover money from buying a house, right? Put it into my retirement accounts and really not be stressed out about money ever again in my entire life. Right? I would lead a great life, be able to do whatever I wanted. $1 million would really change a lot for me. Right? $3 million is obviously better, but it's not 3 times better for me than $1 million. Right? It's not so much better than $1 million that I'd be willing to take a 50% chance of getting nothing in order to make 3 million over 1 million. Some of you might be jumping at the chance to take option B here, but my guess is that a few more of you are on my side here, right, of switching from B to A once we raise the stakes a little bit. And even some of you who are willing to risk 1 million for 3 million, maybe if we turn this into $1 billion versus $3 billion, you start to feel like, you know what, I'll just take the billion, right, and not risk anything. So what this means is that this analysis we've done here, right, where we talked about the average amount of money that you're going to earn, isn't quite adequate to describe people's choices. And the reason it's not adequate to describe people's choices is because when I'm making a decision like this, I'm not just thinking about how much money I expect to make. I'm really thinking about something like how happy that money makes me. Right? In other words, $3 million isn't 3 times as good for me as $1 million. So maybe the way we have to think about this, right, instead of thinking about expected number of dollars, is to think about this in terms of preferences. Right? In order to say, there isn't an objective right answer, right? Everyone chooses the option with the most money. Depends on what I care about. So if I wanted to express this in terms of preferences, right, using all the tools that we've already worked through in this class, how could I do that? Well, one way would be to say we really have 2 goods here. Right? One good is the money that I make if the coin lands on heads. The other is the money that I make if the coin lands on tails. Right? So I have some utility function in terms of money on heads and money on tails. Right? Okay, so what's this utility function going to look like? Well, to think about this, let's make a couple of assumptions. So the first thing I want to assume is that I only care about what actually happens. Right? In other words, when I'm making this decision before the coin is tossed, I'm imagining myself after the coin is tossed, either with XH dollars or XT dollars, and the person I'm imagining after the coin is tossed doesn't really care about the process to getting the money, right? All they care about is how much they have. So if I walk away with $3 million, I'm going to be as happy as $3 million makes me. If I walk away with $0, I'm not going to spend the rest of my life kicking myself because I could have made $1 million, right? So in that case, right, if we only care about what actually happens, then we can say that I only care about XH to the extent that XH is likely to be what I get, right? So I'll say that I've got some probability of getting a heads, some probability of getting a tails. The more likely a heads is, the more I value XH. The more likely a tails is, the more I value XT, right? I'm also going to assume, right, implicitly in doing this too, I'm also going to assume that I know the probabilities, right? I know my probabilities. Then the last thing that I'm going to assume, which in this case is very reasonable, is that the value I get from XH and XT doesn't depend on whether heads or tails are flipped. We call this non-state dependent utility. All it really means, right, is again, what I care about is the number of dollars I walk away with in my pocket. Right? In that case, I'm going to say what I'm going to weight with a probability pH is the utility I get from XH dollars. Right? In other words, how happy I am with $1 million, or how happy I am with $3 million, depending on which bet I pick. Right? And what I'm going to weight with probability PT is going to be how happy I am with XT dollars. Essentially what I'm saying here, right, is that my utility over XH and XT is just going to be my expectation of some function little u of x, right, where little u of x tells me how happy I am with different numbers of dollars. Right, one thing that's important to point out here, right, this thing is my utility function. These little u's are going to be what we'll call cardinal functions, right? In other words, the actual shape of this thing is going to matter. The numbers are going to matter relative to each other. Cool. Okay. So this is how I'm going to try to choose my bet, where I'm going to say which thing, not which choice is going to increase the number of dollars, result in the highest number of dollars in my pocket on average, but rather which choice is going to result in the highest happiness on average. And the only thing we've got left to think about here is what this little u function should look like, right? What is my utility value of money? So for me, right, what I said when I thought about this is essentially that my first $1 million would be more valuable to me than my next $1 million, right? Probably my first dollar is more valuable to me than my 1,000th dollar, which is more valuable to me than my 2,000th dollar. But also, of course, that for me personally, more money is always going to be better, right? I'm never going to say, oh, you know, I prefer not, you know, please keep, right? I'm always happy to take a little bit more money. So I want a little u function here that is increasing when I increase the amount of money, right? So du dx should be greater than 0. But the marginal value of money should be decreasing as I increase the amount of money, right? In other words, the second derivative should be less than 0. So we've worked with a lot of functions that look like this, right? What's one example? Let's say that I said u of x, u of x is something like ln of x, right? In that case, I would say du dx, the marginal value of money, would be 1 over x, squared u dx, right, the derivative of the derivative, would be negative 1 over x squared. Right? Exactly what we wanted. Likewise, I could say, right, I could have a u of x like x to the 1/2, right? The u dx would be 1 over 2x to the 1/2, right? The squared u, the squared x would be negative 1 over 4 x to the 3/2. Great. And what this means is, if I wanted to graph my utility of dollars against my number of dollars, the slope would be getting flatter and flatter and flatter over time. Right, let's say I had, for example, u of x equals x to the 1/2. Right, this would be what the graph looks like. And what this would mean is exactly what we've talked about, right, that having $1 million versus 2 versus 3, right, that having $1 million is not 1/3 as good as having $3 million, it's a lot more than 1/3 times as good. Right, essentially the value of an extra dollar is going to be the slope of this curve. It's going to be decreasing as I increase the number of dollars that I have. Cool. And in this case, right, with this utility function, u of x equals x to the 1/2, it can make perfect sense for me to take $1 million for sure, rather than taking $3 million with a probability of 1/2, right, because the expectation of A is going to be 1 million to the 1/2, right, 1 million times 1, which is going to be 10,000. No, I'm sorry, 1,000. Right, whereas the expectation of B is going to be 1/2 times 3 million to the 1/2, right, which is going to be 1,000 root 3, or about 866. Right? So in this case, with these preferences, it would make sense for me to choose option A over choosing option B. Cool. Last thing left to think about, right, is if these are my preferences, if the reason that I'm not willing to risk 1 million to make 3 million, why wouldn't this be exactly the same story, right, if I was choosing between $1 and a 50% chance at $3? Well, one possibility here, I think a very likely possibility, is that if I'm choosing between $1 or $3, the rest of my assets matter a lot, right? In other words, it's not just the $1 prize that I've got in my pocket, right? It's not just that $1 prize that you've got in your pocket. You might have other assets or other expected assets that matter a lot in this story, right? So if I already had, let's say, $10,000, then the marginal utility of $10,001 is going to be very, very, very close to the marginal utility of $10,003, right? So for small amounts of money, I'm going to make decisions that look a lot like just maximizing the total number of dollars in my pocket. So as a result, right, if we think about these sorts of choices, we think about why some people might choose option A, some people might choose option B, there's really two things to consider. One thing to consider, right, is that maybe people have different preferences. So maybe I have preferences like u of x equals x to the 1/2, but you have preferences that are something like u of x equals x to the 9/10, right? So your preferences are going to look much closer to just being a straight line, right? And as a result, for you, maybe your utility of getting $1,000 is pretty close to 1/3 your utility of getting, $1 million is pretty close to 1/3 of your utility of getting $3 million, right? So one thing might just be, some people have different attitudes about money than others, right? If I care a lot about having, a relatively modest life, but don't care that much, right? I really want to protect my ability to have a middle-class existence in LA, but I don't care that much about being super, super rich. I might be less willing to take risks with money than someone who is dreaming of driving a Lamborghini, right, and is willing to take the risk of ending up very low income. But the other reason, right, that matters a lot, and this is what we saw with the $1 versus $3 thing, the other reason that matters a lot is that people start out with different amounts of money, right? So if you're Jeff Bezos or Bill Gates or Mark Zuckerberg, choosing between 1 million and a 50% chance of 3 million is probably a lot like you or I choosing between $1 and a 50% chance of $3, right? Likewise, if you're Bank of America, right, you might be willing to treat the decision to risk $1 million for the chance to make $3 million as being essentially just about maximizing the total number of dollars, because all of that is a drop in the bucket in terms of your total assets. So what we're going to talk about next video is how that, right, the relationship between a relatively deep-pocketed person and someone who is more affected by changes in income can result in markets for sharing risk.